Hey guys, what's up? Eddie Alho here with KissAnalog.com. Hey, today I want to do an inrush current measurement. I've done something like this before. I want to show you a pro tip, okay? The correct way to do an inrush, or one of the correct ways, and at least one of the bad ways, or a couple bad ways to do it. And some gotchas there. And also the difference between the two types of inrush current. Okay, at least two different types. So let's do this. And by the way, the fried mule kind of asked for some of this, and he wanted to look at the setup. So I'm going to try to show you the setup as well, okay, so that you could reproduce this test on your own bench. All right, I hope I captured enough. Let me know if I did, and thumbs up fried mule, thumbs up to the video if you like this, okay? Thanks guys. Let's do this. I'm going to try to make this kind of short. Let's do it. Okay guys, so this is the setup. I've got this meter, the Fluke, reading the input voltage, and this Tektronix TX3 reading the output voltage. And matter of fact, I think I'll turn it on so you can watch it come up. But this is a Handtech CC65. I've got it set at the 1 millivolt per 100 milliamp division. There's also the more sensitive 1 millivolt per 10 milliamps. I think this scale is good for 2 or 3 amps, and this one's good for like 65. So I've got it set up there, and then I just push this to degauss it a few times. And so here's our little power supply, our little boost converter. The input voltage is these two cables here, and the output going to the active load are these two here. And then I've got two probes, but I'm actually only looking at this one, and this one's looking at the drain of the FET, the switching FET. So what that is, if you look at my boost video that I did not too long ago, basically on a boost converter, if the power supply is not boosting, voltage is going from input to output. So this is a FET that's tied to what we call the switching node, and this guy here will pull the voltage down and then turn it and then let go and boost the voltage up. So without this guy running, when we first apply power, we'll see current just go right through an inductor and a FET, an inductor and a diode. I said FET because I think synchronous rectification where we use FETs. This one has a diode, so in fact it's on the heat sink here. So there's some voltage drop as the voltage goes to input to output, but otherwise it goes right to the load. And then when this guy turns on, then he'll boost the voltage up. And let's go ahead and turn it on so we can see what this thing's set for. I hope that glare is not too strong. Hold on a sec, let me just, ow, cut my finger, that hurt. Hold on a sec, let me prop this up. And does that one need to be, okay, I'm gonna prop that one like that. I don't know if that helps. Maybe that's okay. Alright, so here, let me turn on the voltage. Alright, so let's turn on the voltage, bring it up. Whoops, let me get out of the light here. Okay, Mike. Oh, good. The load's coming up. I was afraid it's getting the current limit. Alright, cool. Okay, I'm only putting out about 25 watts, so 20 volts. I got 31 ohm load and 20 volts going in. So here, we'll set it to 19 volts to kind of simulate a 19 volt supply maybe, okay? Alright, so there's the voltage setup. I'll show you the power supply in a moment here. And you can see the little red LED maybe turned on. And this guy won't even get warm at 25 watts. It's rated at 150. I've had it running 100 watts without it getting too warm. So, alright, let me show you the power supply. Move the camera up. Excuse me. Alright, so there's the power supply. It's set for 19 volts, and this side's drawing about 0.7 amps. Now if you've seen me on another video, this power supply has a tracking supply. It has 2 outputs, and this meter is set for amps and this one's set for voltage. If I set them both for amps, you can see this output puts out 0.75, and I've got parallel mode, so this one's putting out 0.7, so it's about 1.45 total amps. Okay, and I can put this one to volts or this one to volts, and they're in parallel, so they should be about the same. So then I just put one on amp so I can watch the amps. Okay, so that's the power supply. And then here, let me swing over and show you the load. Oh, I should have my other lens on so I can zoom closer. So, okay, there's the load. It looks kind of funny in the camera, but 20 volts. I set this to ohms like this. I'll do a video on this one day. And this one has 25 watts. This is what you call an active load. It's a Konkin KP184. Okay, so that's my load. And now let's look at the scope. And I'm going to move this camera so it looks at gets a better look at the scope. Okay, here, let me move the camera. All right, before I move the camera to the scope for a better picture, what I want to show you is this meter. It's running right now, so if I'm going to decouple it, I have to disconnect, because you can't decouple it when you have current running through it. Okay, so you pull it out and then just hit the decouple button a few times, and then I put it back on the wire. Now, I've experimented. It's kind of funny. This meter, nice meter for the price, like 60 or 60 bucks or something like that, $65. But it's funny because it did not have an arrow showing the current direction. Usually they tell you which direction that current's supposed to go through this. So from plus to minus, it's supposed to go that way. So from the power supply, it goes down that way and in. Okay, so that's kind of how that's set up. All right, and then, oh, by the way, one quickie I want to show you what I'm going to do is up on the power supply. Okay, just a little quick thing on the power supply. What I'm going to do is, when I do the inrush current, I'm just going to pull this out and put it in, okay? Because otherwise I have to move this up real fast, and I can't quite do that. And turning on the power supply would take way too long. So I'm just going to pull this out and put it in. And actually, that's a nice way to do it, but if you do it too many times, you're going to cause little arc, you know, some little carbon tracks on your connectors where it's arcing, so you don't want to do that too much. But I'll do it just for this video, okay? Okay, now I'm going to move it to the scope. Okay, now that's the scope, and I haven't done anything to set it up. It's just, I turn on the power supply and it's just capturing or whatever. Now, one thing I can do, let's just try this, just see what it does. I'll hit the auto setup. Alright, that's interesting. So the voltage waveform, you see that where it put the reference? I'm going to pull them down here. I want to pull the voltage out of the way. Now this is the voltage on the FET, which I kind of show in the boost converter video. Now this is the trigger. Now the trigger's triggering on the current. See how it's purple? So let's see what it did for trigger. Okay. Now the other thing is, see this arrow here? The trigger's off the screen. So I'm going to push this button in. Oh, in the position right here. And it centers it. Okay, now you see how it's triggering off of this and here. So this current's doing some kind of funny stuff, so it's kind of wobbling all over. So let's zoom out. Yeah, see what the current's doing? Here, I'm going to freeze it. See how it's running and then it takes a dip? Because the power supply stops running there. You see how it's not quite as bright and then not bright here? The power supply stops running. So the current drops down and then it comes back up when it kicks back on. So I'm not drawing very much load off this thing, and I'm going from 19 to 28. So it's not a big, very big load. So sometimes the power supply's shutting off until the output voltage drops down and then it turns back on. So that's why we're getting this kind of crazy stuff. Okay, so we're going to ignore that because all we really want to see is inrush current. That's what we're going to focus on. Okay, so I'm going to sit, this is 200 microseconds. I'm going to capture even a little bit more data. I think I'm going to go to milliseconds because this scope has deep memory. So once I capture it, well, I can show you. Once I do this, see that little darkened spot? That's what we see down here. And I can make that smaller and zoom in. That's what deep memory does for you guys. So that's what's nice. You can see all this craziness, but at the same time you can focus on that little spot right there. I can freeze it, and I can use the position, and I can move across to see what each one of those sections looks like. Okay, so this is output voltage. This is 10 volts per division, 10, 20, 30, 40. Is that right? 10, 20, oh, 30 volts. Sorry, I counted them wrong. So it's 30 volts up. It says RMS is 21.38. Current's 1.79 RMS, it says. So anyway, that's what that looks like. Okay, so let me just go back to this. So this way, and you know what? I'm going to move this trigger over here. So once it triggers, I capture all the stuff. Because otherwise, what happens before it triggers on an inrush, I really don't care because it's going to be pretty much zero and then it's going to jump up. So let me move that little arrow over there. I usually, I don't know, it's just a habit. I usually put it about the second frame. Alright, now let's run this again. Now I'll put this on. Okay, I'm going to pull out the cord out of the power supply. Okay, it's gotten to zero. And the current is 1 amp per division. Now I know the inrush is going to be a lot higher, so I'm just going to go to 10 amps per division, guys. And now see where the trigger's set? It's set for about 3 amps. I'm going to go to 5 amps. Alright, and go to single mode. So now single trigger means it's going to snap a shot one time, it's going to trigger and freeze. Okay, it's going to capture all the data that it can and then freeze. So let's go ahead and put the banana jack in the power supply and see what happens. We'll capture the inrush current. And nothing happened. Okay. Sometimes you got to mess around with this trigger. Let me see what this is set. It says it's set up on DC, rising edge. It's set up on current, which I guess is what I want. Edge type. I'm going to turn off the noise. Alright, let's try that again. Maybe I'll go a little bit higher just in case. I don't know. Now this power supply can only put out 6 amps continuously. Alright, so we're ready to go, it looks like. Let's see if it'll trigger. There it goes. Alright, I'm going to pull the power supply out so it's not running. And that way it'll discharge the capacitor so we can try again if we want. But actually this one looks like it caught everything I wanted to show you. Well, I think so anyway. The current's coming along here and it has this big old jump. Hope you can see that. Hold on a sec, I'm going to change lenses so I can really zoom in for you. Okay guys, how do you like that? That's a nice lens, right? So we got this big old spike here. That's the inrush current. This is what I want to point out. There's 2 inrushes. This one is usually the one that causes the arcs and the welding of contacts, the damaging of your switches and so on. And also it causes a huge inrush to your components. So pretty high current. We're going to measure that, okay? But then what happens, the current drops down and you see the voltage here rising up. It's going to the load right here. So this is going straight to the boost converter to the load. But then the voltage starts to ramp up here and the power supply starts to try to boost. Okay, so it turns on. This is where it's boosting. then it turns off, and it turns on, turns off. So you can see it boosting, turning off and on. The reason it's doing that is because these little peaks of current, I've got this current set at 10 amps per division, and I have a 5 amp supply, right? So, or a 6 amp supply. So here, let me zoom in on that a little bit. It's kind of digitized. I call that digitized. I need to capture another waveform to see that clearly. But you can see it goes up one grid. Let me see if that's on a grid for sure. Looks like it wasn't quite on the grid. See, that shows 5 amps. So that shows right where it's supposed to be. I like that about the Siglant. Anyway, it goes up one grid. That's 10 amps. That's over the rating of this power supply. It's kind of a not a very stiff power supply, we call it. You know, it doesn't have a whole lot of current capability. So anyway, it goes above that, and then when the boost converter starts to switch, it tries to pull another 10 amps. See how it goes up another grid even more? So every time it does, it basically goes in the current limit and the voltage drops. But when it does it, see how it looks like a staircase, a ladder? It slowly charges up the output capacitor until it starts to run, and then it runs, and it current limits again, so it drops down, and then it tries this a few times. So I think what's happening here is it's cross between overcurrenting, and then it reaches regulation on the output, and then it drops down, and then it tries to regulate, drops down, tries to regulate, and it does that over and over until it finally starts to is kind of overcorrecting here. And then it finally starts driving straight down the road, and you get nice pulses here. So, 2 inrushes. The big old spike caused by input capacitors, and then the rest of this is load inrush. This is from the power supply starting up into a load, because the load's connected, and it's a constant 31 ohms right now. So it's not very many watts, so it's not even a very big load. I had to turn it down. This thing's capable of 150 watts, this power supply, with this boost. At least that's what it's rated to. And I've had it at 100 watts, but my power supply, my lab bench supply, isn't really capable of supplying that current. So especially during inrush. So I'm kind of showing you an inrush on, say, a 25 watt supply. All right, so that's the 2 inrush currents. Now let's see how high this inrush current actually goes, okay? Now to me, it looks like it went right off the screen. So I think it did. What we want to do is expand this, and we can just do it this way, and then scroll over. Or, see, that's all the information we grabbed. I can go back to here, and then I can push this in, the zoom, and I can open up this window so I can move it quicker. Now I can move it over here, and there's that spike. I'm going to put in the center of the screen down here. That way it's easier to zoom in on it. Whoa, overshot it. Shoot, that's one thing when I'm moving too fast, I keep on overshooting. Here we go. Okay, now let me zoom in the other way. See that window getting smaller, and I'm zooming in, and you can see it goes right off the screen. So if I drop it down like this, look at that. What's neat about the Siglant, a lot of the more expensive scopes I use even will clip that right off. And even the Siglant will, but in this case it looked like it didn't. So it captures data that looks like it would be otherwise off the screen, which is pretty cool. I'm not sure what the limit is on it, but sometimes it clips it, and other times it goes, you could see how far it was off the screen. But anyway, okay, now we're 20 amps per division, 20, 40, 60, and a little bit higher. Okay, now one thing I want to kind of take a step back right here. So it looks like a little over 60 amps. We can use the scope to tell us what that is. We don't really care about the RMS current. I'm going to show you how to set up the scope. this is one thing the fried meal kind of asked for, is to show how we do the setup, and I think that's useful. So let's go to channel 2, which is the current. Now you can see the units, they were volts. I changed it to amps. Inverts off. Okay, this is page 2 of 2. Go to page 1, it's 1 megohm, that's where I want it, and the probe is 100x. So if I push this, it gives me, it was 10x for a normal scope probe, but I wanted a current, I'm set at the 100x point, so I put that at 100x. And I do have it on bandwidth limit, 20 meg, which is plenty fine. Now I could turn that off for this test, just to make sure there's no questions about that. And the coupling's DC, so it's just DC coupled. So that way we're measuring from the point here up, because we want to see the DC pulse current, right? Okay, so now let's set up this measurement here. Now what we do is we go to measurement, and we want to go to channel 2. So we go to source, channel 2, and enter that. I could select it by this multi-purpose knob too. And okay, so then I come over here and I go type. Yeah, that's what I want to do. I want to go type, and I want to see max. So I want to see the max, and it kind of shows you what a max is. I like that, how it gives kind of help commands as you go along. It's kind of help on the fly. Now, y'all see this RMS? I'm going to go over there and turn that off. I'm just using the multi-purpose knob next to the screen. You can't see that, sorry. Here, I'll zoom out a little bit. I'm just using this knob here to move around. And then I push it in and push, you know, to select or deselect. Okay, so that's what we got. We got max. That's what we want. I have duty cycle on this other stuff. I'm going to just leave it. I don't care. Push button, get rid of this window. And look at that. It measures 60.8 amps. Okay, let's make sure we didn't clip anything. I don't see it. It doesn't look clipped. But let's just grab another measurement to make sure. Hit single. I just hit the single button over here, okay? Alright, now I'm gonna go ahead and put the banana jacket back in. Let's see what happens. It's been out all this time, so the capacitors are totally discharged. Here we go. I'm gonna try to get it without bouncing. Good. Maybe I should, oh no, I did bounce. Look right here. There's a pulse there and another pulse there. I can only see one here because there's only one inside that window. And that guy is 63 amps this time. But he didn't charge completely because I kind of bounced. Here, I'll zoom out a little bit. See the other pulse? He's 40 amps. So I got a 63 amp and a 40 amp one there. 40 plus. So that's kind of good that I bounced, just to show you that happens sometimes. So you have to do this multiple times. And here, let me pull it out again. And I'm going to hit the single trigger button again, right over here. Okay. Now, alright, here we go. I'm going to pop it in there right now. Shoot, I got another double. It's kind of hard because, you know, when you're just putting the banana jack in, it bounces. So now it says 63 amps. God, it's almost exact measurement. This one's a little bit lower. It's about 30 amps. So these are the inrush current spikes. We'll do it one more time, okay? Now, that's the one, like I say, that causes a little arc, the spark. And then the other one is, so this one causes those kind of problems. This other inrush can cause problems with, like, say, a lab power supply, like the one I have, that's not quite robust enough. And it kind of causes some issues with the power supply starting up. Now, by the way, when I design power supplies, I usually design them so they have a soft start, so they can softly start, and it's possible that maybe at least alleviate some of that problem, if not all of it. But okay, here we go. We're gonna go back to single mode, and I just wanted to stall in there and let it discharge. Okay, I'm going to try to pop it in there real fast. Shoot, I could feel me bounce on that one. You see this? That double pulse? That's only 43 amps, but look at this spike over here. See that one right there? That's 20, 40, 60 amps. Look, 60.8 amps. Wow. That was a pretty bad bounce there. All right. One last time, guys. Because I don't see anything above 60, and I think I'll tell you why. Okay, here we go. Hold on a sec. One more time. Ready, set, go. Hey, there's a single shot, it looks like. Oh, it's kind of a double bounce. They're right on top of each other. Look at that. So it's about 49.6 amps here and about 30 amps there. But you get the idea. So, and then we also have this Inrush, okay? Maybe I should show you a little close-up of that real quick. Now, guys, I think the reason I'm hitting my ceiling is I think I also have a limitation with my Handtech CC65 current meter, my current probe. It's rated at 65 amps, which is right about what we're hitting. So I think it's saturating the coil in that pickup on that current probe. So when you have that problem, it's expensive to get those other current probes. They're quite expensive. Another way to do it is put a small sense resistor, just a small resistor in series, and take a voltage measurement off that. That'll also help limit your current though, your inrush. So it's best to have a good current probe. So shoot, I'll tell you what, there's another way to do it even. Instead of having one power wire that I have, I could run 2 power wires and in parallel and probe just one of them, and then I could probe the other one to prove that they have the same current, and then that way it drops the current in half, because half the current would go down one wire and half the current would go down the wire I'm monitoring. So that's another kind of trick. Kind of another pro tip, right? Okay, so hey guys, I'm going to scroll over to look a little closer to this other inrush current. This is usually the one that's specified. That one, because that one can weld contacts and relays and stuff like that, switches. So you want to limit that big inrush current. You know, I've shown some other videos where you use thermistors to do that. Okay, now see this load current here, a little bump here. Now what I'm going to do, you know what I'm going to do so I can show you this better? I'm going to do this kind of thing so we can zoom in on it, get a better picture of it. I'm going to pull this down to right down here. I'm waiting for that to say 3 amps. Right, oops. I'm at the 3 amp line right there. That's 3 amps below the center. That's what that means. Okay, now let's see if I... Okay, I'm going to turn off the zoom. Here, I'm going to capture another inrush, and I'll show you what I'm talking about. Okay. Okay, so now this guy's way off screen this time, but see how I got a little bit more amplitude there? You know, let's just do it this way this time. That way I can use the full screen. So I'm going to just do it this way. Instead of the zoom function, I'll just zoom it this way. So, whoops, got a little too far. So see, the voltage is coming up. The boost converter starts to switch. The current goes way up. And now we're sitting at 2 amps per division. So we're 2, 4, 6, 8. See, it's only a 6 amp supply, so 2, 4, 6. So that line right there is the max that thing's supposed to put out. So then it overshoots like that and boosts, goes into overcurrent. And so, but see, it's staircasing, it's charging caps slowly on the output. So each time it gets a little bit higher. So that's kind of what's going on there. So that's kind of the inrush to the load. Okay, now I'm going to come right over here and zoom on that part. So now this has finally gotten the caps charged up high enough, and see how it's starting to regulate here, and the current starting to stay consistent. But still, if you go 246, I'm still a little bit above the rating of the power supply. So that is the load inrush. All right, so now we see the two different inrushes. I'm going to show you another part of this that can catch people off guard. What we're going to do is we're going to go to the Tektronix power supply, where it actually has an on-off button, has a button they call an output button, where you enable the output, so you can just hit that button. You can set up the voltage and current, then you hit that button, and it has an internal relay that turns on the output. But I'm going to show you the gotcha there, another pro tip. Alright guys, so I've put this on single mode, and I'm going to turn this on by the button here. Look at that. Now it stops. I'm going to go ahead and turn this off so let that cap discharge. So now here, let me zoom in so you can see this better. Look how nice that is. Came up. That's 5 amps per division. So 5 amps, there's a little bit of an overshoot there. Here, let me zoom in on that. Make this a little wider so I can scroll over there faster. Okay, see that? Now if I have to come in a little bit tighter so it makes it more obvious what I'm showing you here. But here, let me see how that's 2 amps per division. See how it has a little bit of a blip, and then it's fine. Well, that's 5 amps per division, right? So that's what it looked like. Here, let's back off. So yeah, 5 amps looks pretty good. Then power supply tries to turn on, same kind of thing. It actually shuts down, the voltage pops up, then it tries again, and eventually turns on the power supply. Okay, and so that's because I just hit the on button. So we missed that big inrush current to the capacitor, right? That's because, pro tip, that is not the way to do inrush current. The power supply will ramp up the voltage enough that you don't see that inrush current to the capacitor. Or if you do see it, it'll be much less pronounced. Okay, now watch this instead. Pull this out. Let me hit the single trigger. Okay, now this is much better way to do it. Oh, no trigger. Oh, sorry. There we go. Had to hit it. Now look look what happened. Even though that power supply is only capable of 5 amps and it's set up for 5 amps, look at that gigantic spike. So it has a huge spike, and then so now it looks more like the Instack power supply. So here, let's zoom in on that guy. And you can already tell that, here I'm going to put right in center of the screen, right there. You can see how much of it got clipped off. So if I go back down here, 10 amps per division, even 10 amps per division looks like it might go off screen. So let me go down to there, and this goes single mode. Okay, the jack's been out of the power supply. I'm going to put it back in. it's kind, I forget, okay. Here, let me adjust this current here. Okay, I'll go 12 amps. Okay, now let's go ahead and pop it in there. Okay, so let's go ahead and bring this up to like say 30, I don't know, 35 amps maybe. Let's try that. Okay, I'm gonna go ahead and pop it in there. There we go. Look, I hit a double bounce. Let's try that again. Try to see if I can get a good connection this time. Here, ready, set, go. There we go. So big old bounce. So now it's 20 amps per division. So that's 20, 40, 60 something amps. So you can see that there's a gigantic inrush current. So that's the pro tip here, is this, you know, the first inrush current is due to capacitors. That'll be the big one. All right, so anyway, you have two parts of inrush current. That guy here, let's take off the zoom. You get the big spike from the input capacitor, and then you get the load inrush from trying to start the load. In this case, this other power supply is only capable of 5 amps, where the Instax was 6 amps. You know, they both start up eventually, but you can see that they try and try. So they actually operate pretty similarly, right? But that's the load inrush current right here, where the boost converter is trying to operate. So you get an inrush current from the load and the converter, depending on how the converter's been designed. And if the converter's been designed so that you don't get all this stuff, so you get a soft start, you will still see an inrush current caused by the load. Okay guys, so just to wrap it up, big inrush current from the capacitors. Both power supplies did that. Turning the on-off button for the load or for the power on the lab supply is not the way to do it. Connecting the banana jacks the proper way, although doing it into the jack of your power supply can cause pitting on your power supply, so you don't want to do that. Okay guys, so the best way to do it is just take your banana jacks and do it this way. Just connect it this way, you know, push them that way, grab 2 pieces of wire, you know, take a switch that you're going to just toss and use a switch. Use something, a blade switch is a nice way, but you don't want to really plug it in your power supply the way I did it. I did it because I was only in it a few times and I wasn't too concerned. So, but I wouldn't do that over and over, okay? So, anyway, hey, hope you liked the video. Give us a thumbs up if you like this one. And thumbs up to the Fried Mule for making this recommendation that to show how to do the setup. Thanks.